Hello everyone, my name is Fakran. I'm a technical sales consultant from Aveva. So today I would like to talk about Aveva Predictive Asset Analytics for early warning. We're going to share with everyone on how these artificial intelligence driven solutions can help asset owner to reduce unplanned shutdown and increase plant performance. Okay, before we go and talk in details about the solutions, let's talk about the challenges that have been facing by all these asset owners globally. So, based on the study that have been done by ARC, the unplanned shutdown has basically caused the asset owner around $1 trillion of losses globally. That is coming from the loss of the repair costs and then loss of the production income due to these unplanned shutdown failures. So talking about the failure pattern, surprisingly, only 80% of the failure pattern is basically age-related failure, while the balance 82% is coming from random sources. That means the traditional approach that are using reactive maintenance or preventive maintenance program are not the right track to cover or to really remove unplanned shutdowns at the asset. To cover this random failure, the asset owner needs to deploy more advanced condition-based monitoring or the new predictive technology for early warnings. Then only from there you can cater or address the bigger portion of this failure issue to prevent unplanned shutdown. Aveva Predictive Analytics utilize machine learning algorithm and pattern recognition technology to produce the early warning to the user. So how this works? So taking for example, we want to use this predictive technology to monitor a pump. First step is basically to build a model regarding that specific pump. So we need to basically utilize the historical data for the pump for a certain period of time. For example, we take 6 months of the historical data for the pump, do the data cleanup, and define the clean data as the standard operating profile or the model of the pump. What does that mean? It's basically we define a standard operating portfolio for the pumps. So it means that it represents on how normally this pump is behaving in the process at this asset. So when we want to deploy, so the solutions we utilize the pattern recognition technology to produce a predicted value from the model that we just created. So this predicted value is then will be compared versus to the actual data value that is coming from the historian. So any deviations that have go beyond the allowable threshold will be created an alarm to the user. So this alarm is basically the early warning indications that we talked about earlier. So this early warning indication to basically give the users a notification and idea that is something abnormal happening at this specific asset. So from there, the user can plan a follow-up actions to rectify or to further investigate this issue. Let's talk a bit more details on the monitoring approach. So we are trying to compare the traditional monitoring approach versus the predictive asset monitoring approach. So in the traditional monitoring approach, the alarm threshold line is flat. So it means that when the alarm is triggered, the equipment is already fail or very, very near to fail because the damage has been accumulated prior to reaching the limit. In the new predictive asset monitoring technology, so the system utilizes its pattern recognition technology to have a high and low thresholds that is compared to the actual signals. So in these situations, as soon as the anomaly is detected, between the predicted value versus the actual value. So the early warning alarm is straight away given to the user, and then the user basically has ample time to react on it, so that they can plan a proper rectification activities or rectification plan to further prevent from unplanned shutdown to happen at the specified asset. What type of early warning indicators can be given from these solutions? The first one is the overall model deviation. What is the overall model deviation? The overall model deviation, so-called the health index of the asset that we are monitoring, it gives a clear idea on how far that the actual value has been deviated from the model value of the asset that we are monitoring. So the value is in percentage. For example, the higher the percentage go, means that the higher that the actual value has been deviated from the standard operating profile of the model. It means that the equipment is not healthy, and then when it goes beyond a certain alarm threshold, it will trigger either warning alarms or alarms that can be then given to the user. So not only that, the system also can be able to provide fault diagnostics on the issue that is happening. So basically, what is the likely fault conditions for the specific alarms that we are looking into right now? From there, the system also have the capability to produce or prescribe prescription action plans for the user or to help the user to plan or carry out the rectification works of the issues. Last but not least, the system also can provide a specific or individual signal contributions that affect the issue that we are talking about. So the user can basically scroll and identify which sensors that is contributing to the issue in this specific time frame. Aveva Predictive technologies can be deployed to all the industries, from oil and gas, chemical, F&B, mining, to power industry. And this technology is basically vendor or OEM agnostic, meaning that as long as the type of the equipment can be covered by the system, it can work with all those equipment manufacturers or OEM that are available in the asset. Let me share with you the success stories on predictive asset analytics deployments in Duke Energy, USA. So the predictive system that is installed in this power plant basically gives the user an early warning indicators that is related to these field progression changes at one of the LP turbines that they are monitoring. So from there, the plant operation maintenance team has carried out a further plan to check on what is actually happening. So they go to the site, open the casing, and then they found that the upper half of flow sleeve of the turbine blade was no longer supported by the lower half, meaning that the blade is no longer at its actual or original positions. So the blade has basically scratched with another part in the turbine. For example, it scratched to the casing. Although the damage is minor, but they basically avoided from more serious things to happen to any other blades or equipment inside the turbines. Estimated around $4.1 million have been saved from this accident in terms of the repair cost and loss of production income to the owner. With that, I finished my predictive asset analytics presentation. Thank you.